we are starting a new topic, which is effect of substituents on orientation. In the previous session, we have discussed the effect of substituent on reaction rate. So reaction rate is one effect by the substituent. The same substituent is going to exert one more effect, which is on orientation. So I want you to understand this thing, that the substituent which was exerting effect on the reaction rate is also going to exert one more effect, which is on orientation. Now with orientation, what I mean, let us understand with this scheme. So suppose there is a benzene over which one group is already present, and there is going to be one more round of electrophilic substitution reaction in which one electrophile has to add on the benzene, and there are 5 positions over which it can add, because out of the 6 positions, 1 position is already occupied by the substituent which is already present on the benzene, and the incoming electrophile has 5 possibilities or 5 sites to add upon. It can add on the site next to the group which is already present, and this site is known as the ortho site. It can also add on the site next to the next carbon, and there are 2 sites like this. So these 2 sites are called meta sites. It can also add on the far away site, which is called the parasite. Parasite, not parasite. So if we see the possibility, then the percentage that could be expected is 40% for the orthoisomer. Let us decide as per the probability distribution. So out of the 5 possibilities, if 2 are ortho, then there are 40% of the chances that the incoming electrophile can add on the ortho position. Similarly, 40% chance that the meta product is formed. And there are 20% chance, because that para position is only 1 position, so there is only 20% chance that the electrophile will add on this particular site. So this was the distribution of product as per the probability. Because if you have put this reaction, you can expect these 3 types of products, these 3 isomers, in this percentage of yield. But this was just the expectations. It does not happen in the practical scenario. Let us see the examples. Suppose there is O-methyl which is already present. This means methoxy group is already present on benzene, and if you are trying to do nitration, that means you are trying to add NO2 group on this methoxy benzene, then 40% of the product is ortho product, 70 or 60% of the product is para product, and there is almost to nothing meta product. So no meta product in this case. Then there is a trend in which 95% of product was para product and ortho and meta was next to nothing. So only para product, something like this, and a small amount of ortho product in this case. And there is third case where the nitrobenzene is there and we are trying to do nitration, and meta product was obtained in 95% yield, a very exclusive product, and there was almost to nothing ortho in the para product. So you can see that the probability distribution was not getting translated to the practical scenario. So that means there was a trend in the distribution of product. So let us try to decode this trend. Maybe I have told you in the past that the activating groups are always ortho and para directing. This is the trend that is followed, that the groups which increases the electron density of the benzene ring, that means those groups which are activating to the benzene ring, usually direct the product to the ortho and the para site. So these groups are called ortho-para directing groups. So the same examples which we have studied in the activating groups are also the examples of ortho and para directing groups. Similarly, those groups which are deactivating to the benzene ring are always going to direct the incoming electrophile to the meta position. This is the trend they follow. Activating groups are ortho and para-directing groups, and deactivating groups are meta-directing groups. Examples are these. Let us see practically one more time that if you try to do nitration of phenol, you are going to get two types of product, the ortho product and the para product. The ortho product is going to be in the yield of 53% and the para product is going to be in the yield of 47%, and there would be almost to nothing meta product. So activating groups like hydroxy are always ortho and para directing. You can see the other example also, that if you start with nitrobenzene and you try to do nitration, then the product that you will get is going to be meta product. There is going to be no ortho in the para product, so exclusively meta product when there is a group which is electron withdrawing. So electron withdrawing groups are always meta directing. These are the theory things which I have explained to you, that there is a synonymous relationship. Ortho and para directing groups are always activating and meta directing groups are always deactivating. Now there is one exception to this rule. This is being told to you in the form of anomalous behavior of halogens. That halogens are, if you see, are exerts negative inductive effect but plus positive resonance effect. Negative inductive because they are more electronegative as compared to the carbon, so they exert negative inductive effect, while they exert positive resonance effect because they have lone pair of electrons. So the net effect is deactivating, because in this case the resonance effect is weaker as compared to the inductive effect. So the net result is they are electron withdrawing, and they are electron withdrawing, then they are expected to direct the product to the meta site, but that is not the case with these halogens. So these are the exceptions, that in fact by being a deactivating group, they direct the incoming electrophile to the ortho and the para site. One exception only, that despite halogens are deactivating groups, they give ortho and the para product, not the meta product, because these are weakly deactivating groups. These are not so deactivating but weakly deactivating groups. So that is the reason why it happens. So that's it for this session. In this session we have covered the effect of substituent on the orientation, and we have seen some examples also. In the next session we are going to cover the last topic of this unit 1C, which is theory of orientation. So see you in the next session.